Fellow mathematicians, we're going to take a look at another integration by parts problem, but for this one, we're going to increase the difficulty. Now, your choices for u and dv are very straightforward. If we choose u as x squared, the derivative, 2x, the power goes down by 1, which is simpler. So let's try that, u as x squared. All right, du then comes out to 2x dx. And with u as x squared, everything else, cosine of x dx, that's dv. So dv, cosine of x dx. And now we integrate or find an antiderivative to get v. An antiderivative for cosine is just sine of x. All right, we have everything that we need to plug this into the integration by parts formula. So we get u times v, x squared times sine of x, and then minus the integral of v du. So minus the integral of 2x times sine of x dx. All right, and this is where a lot of mistakes are made. And they are almost always due to that minus or subtraction sign. The problem is that the remaining integral that we have here, we're going to integrate that by parts again. And the integration by parts formula has a minus in it. So buried within this integral will be another minus, a minus out front with another negative inside. That'll cancel to a positive. Now, all the sign errors that could be made here, they can all be fixed by using a set of parentheses around that integral. So let me just put a set of parentheses or brackets around that integral. And that is one of the best tips for the calculus sequence. Use parentheses. All right, from here, the integral inside, we're going to integrate by parts again. And for our choice of u, we need to be consistent. We chose u as the power of x. Do not switch your choice for u in dv here. In other words, do not choose u as sine of x. You're just going to undo all of your work and go back to where you started. So stay consistent, u as the power of x, dv as the trig function. All right, so u, we're going to choose that as 2x, dv as sine of x, dx. Differentiate, du comes out to 2 dx. And find an antiderivative for sine of x. That's negative cosine of x. All right, let's just carry our work down. So carry down your first uv term, x squared times sine of x, minus, followed by our parentheses or brackets. And then inside, we're applying the integration by parts formula, but now to our second choice of u and dv. So apply your integration by parts formula, u times v, negative 2x times cosine of x, and then I'm going to include all the signs here, minus, from the integration by parts formula, the integral of v du. So the integral of negative 2 cosine of x. And then close the parentheses or brackets. Now with practice, you can combine several steps together, but here I want to be careful with my signs. The negative from your antiderivative and the negative from the integration by parts formula, you can bring that negative out front of the integral to cancel, and we can rewrite this as plus. So let me just take care of that small simplification. Everything else will remain the same. But now bringing that minus in front of the integral, we can cancel the minus between the terms there to write that as now plus the integral of 2 cosine of x dx. Now, it's okay if you want, you can bring that factor of 2 out, but for integration by parts, I like to keep all of my factors inside the integral because they could be brought out and then forgotten by not using a set of parentheses. So, good tip, keep your factors in there until you get the hang of this. All right, now notice the remaining integral you have here inside the parentheses or brackets, that's just a basic antiderivative. Your antiderivative for cosine of x is just sine of x. The factor of 2 stays. So this integral here, that just evaluates to 2 sine of x, and we're basically done. The rest of the work is just cleaning up and going through some algebraic simplification and being careful with our signs. So let's just rewrite here. We have x squared times sine of x. We have minus, and then the set of parentheses or brackets, minus 2x times cosine of x. And then this integral, we evaluated that to 2 sine of x. So plus 2 sine of x. And since we're done integrating, we can put our plus c at the end here. Don't forget that. Us professors love taking off points if you forget that. If you forget your plus c, minus 1,000 points. All right, so if we're just careful with the algebraic simplifications, we can distribute that negative inside and change all of the signs. So for our final form, we get x squared times sine of x plus 2x cosine of x. And again, distribute that negative there, minus 2 sine of x. And again, don't forget your plus c. And at that point, we are done. This problem required 2 integration by parts, and it's not a coincidence. Basically, the power of x out front, when you have a power of x times a basic function like cosine, sine, or e to the x, the power of x tells you how many times you're going to integrate by parts. Now, as it turns out, there is a shortcut for all this work called the Tabular Method, which I have linked down in the description, so definitely check that out. But make sure you can go through integrating by parts twice the long way here, especially if you're going further in science or engineering, where some of your problems or calculations could become very long. And this is a good way to build organization for your work. Hope you enjoyed the video. If you did, support the channel, like and subscribe.